Hey there, my name is Alejandro, and welcome back for day 51 of me doing the NeetCode 150 challenge. So today we're doing our very first LeetCode medium linked list problem, and without further ado, let's get straight into it. Okay, today we get LeetCode medium, problem 143, reorder list. And it seems like we've solved this before. When have we solved this? Ding ding ding, June 6, 2024, which I think was before the daily LeetCode challenge that I started. Okay, you're given the head of a singly linked list. The list can be represented as L0, L1 all the way, okay. Reorder the list to be of the following form. L0, Ln, L1, Ln minus 1, okay. You may not modify the values in the list nodes. Only the nodes themselves may be changed. Okay, okay. Okay, which means I probably cannot keep copies of the nodes. Which means, okay, I cannot do a lot of things. So, okay. Let's think here, right? So, definitely, I will need to do an initial parsing of the list, right? I want to make, L0's next element is Ln. The only way I can fetch Ln is by at least doing one singular parsing of the linked list, right? So I must parse the linked list in the first place. Modify head in place instead. Okay, I mean, one way we can do this is like, we add all the nodes to an array, right? What, do we have to do this in like O of 1 space? Extra space, I mean? Because one way is like, you reverse a linked list, maybe, and then from that point on, you just like, pick and choose as you want, and there you go, bada bing, bada boom. Another way that I'm thinking of is like, you literally add all the nodes into an array, and then it's like, you modify the array in the way that you want it to match this, becoming this, and then it's like, and from that point on, it's like, go through all the nodes inside of the list, and set their next pointers, right? So that's honestly the way that I'm thinking of doing this, right? Let's take an array here. Let's do this. While head order append, head, right? Head is equal to head dot next. Step 1. Add all nodes in order to array. Step 2, reorder array. Fashion similar to problem description. As per problem description, right? So essentially here it's like, we want, so the next 0 stays the same. Oh, wait, this is weird. It's essentially, oh gosh, that's gonna hurt with my brain. Okay, so you want to put Ln in here, and then L1 is the next, right? So maybe it's like I have an I and a left and right pointer is equal to 0, comma, length of r minus 1, and then it's like here I'll do while L is less than r. That's like, L dot next, r of head dot next is equal to r of L dot next is equal to r of r, then r of r, right, because of the last one, so r of r dot next, L plus or equal to 1 equals to r of L, and then yeah, from that point on, oh wait, but L1, no, this is good, right? r minus or equal to 1. Okay, here, okay, let's return r of 0. Okay, so let's first see, like, you know, if we're making mistakes and so on, da da da, bada bing, bada boom. Let's just see. Okay, so here we probably created an infinite linked list anyways, right? So let's think here. Memory limit exceeded. Okay, maybe I do L less than or equal. No, that's even dumber. Okay, so we gotta reorder the list here. I mean, I could add a new list. Right? I can say this is list is equal to, r is equal to this. Create reordered array. Add elements to new array in reordered fashion. So here we can say reordered. Okay, we'll copy paste that just because I cannot spell. Reordered r is equal to this. All comma r is equal to 0 comma length of r. Here we'll say collections.deck. While length of r is greater than 0, reorder left next is equal to true. Pop left if left next, else reorder r dot pop. Next node equals this. Reorder r dot append next node. Left next equals not left next. Right? Then reordered r dot append none. For I in range length of reordered r, -1, reordered r of I dot next equals reordered r of I plus 1. And here don't return anything. Okay. Yeah, so this is R here actually. R. Okay, so this works. We can submit. There we go. Bada bing, bada boom. And okay, so our solution is very slow, right? But it is technically a working solution. So we know how to do it. It's just, there we go. We might, yeah, so we have an unbelievably, terribly slow solution. So now we need a way to do this a little bit better without this janky stuff, right? So essentially the way that I did, in case you're curious, is I use a double-ended queue. I add all my elements to the double-ended queue, and then it's just like, okay, let's create a new array, and then it's just like, you know, add the first one, then add the last one, then add the new first one, then add the new last one, because I'm going to keep popping left and right from the queue every single time, right? And then it's just like, you know, I do is the left next is a Boolean value that I'll toggle every single time. So at first it's like is the left next, then yeah, take the left element, right, and pop that, right? Otherwise pop the right, and then pop the left, and then pop the right, and then it's like, there you go, bada bing, bada boom. until you hit the very end, right? And then at the very end, then it's like you actually do the modification in place. Okay, so that was a lot of complexity for no reason. Now, okay, so definitely I have to do, okay, so I have to at least do a scanning of the list, right? So at least I have to reverse the linked list once, right? And if I'm going to have, O of n extra memory for a whole new linked list, I might as well create an array of all the nodes, right? I might as well use O of n memory however way I want it, right? So, okay, maybe in terms of, asymptotic complexity, this is an optimal solution, but I won't use this as my actual solution because it's just way too janky, right? But I might as well do everything in a normal array, right? So here we might as well do r.append head. Head is equal to head.next, right? Then I want to do some kind of two-pointer approach. 0, length of r. While L is less than R. Can I not do something like that? Whereas like I say, hey, R of L dot next. Yeah, this gets janky really fast, right? Where it's like if I make this guy's next this, then it starts getting weird, right? Unless it's like I solve this problem recursively. But then it's like, right? Yeah, so I could definitely... Oh gosh. No, I'm starting to think of n-squared solutions at this point. Yeah, I mean, the solution we had is not so bad. It's just what is an elegant way of doing this, right? I want to essentially fit in that middle one. So yeah, one thing I can do for sure is I don't do the left next here. I'm going to do L, R is equal to 0, length of R minus 1. While L is less than R. And here I just do next. R.append. Why am I having trouble here? Reordered R.append. The left one, sorry. R of L. Supposed to equal to 1. L is still less than R. Then here we do reordered R.append of R minus or equal to 1. Can we do something like this? Here we get a wrong answer. Maybe I do something like this. And something like this. Okay, and then here, do I even need it? Whoops. I do not. Okay, let's submit this. Okay, so here we're still at 7 ms is the problem. Right. The only thing I'm scared of, right, is what if we start losing data? Okay, I have my array here, right? Let's think about how to do this the best way possible. Got my array. Then I want to do. How can I do this without, like really screwing myself with the O1 stuff? Because I mean, asymptotically, I do have an optimal solution. It's just that obviously it's a very janky, not cool solution, right? So yeah, there's gonna be some kind of 2-pointers idea here. There's just gotta be. Just gotta zigzag my way between, right? So the pointer is, okay, well, L is less than or equal to R. That's like, okay. R is next. Cur head is equal to R of L. Cur tail is equal to R of R. Cur tail dot next is going to be equal to cur head dot next. And then cur head dot next is going to be equal to cur tail. L plus or equal to 1, R minus or equal to 1. Return. Yeah, okay, so here I'm in the infinite loop zone. I gotta relax. So what if there's just 2 elements? If there's 2 elements, what do I do when I have just 2 elements? When I have 2 elements, it stays the same. When I have 3 elements, it gets different. Okay, first of all, let's try with L less than R. Okay, so I make my current head equal to this. Less than R minus 1 maybe. Jeez. Memory limit exceeded. How? Wait. Wait, I see. Is it L plus or equal to 2? I gotta I gotta think about this. The point is like, okay, current head is equal to R of L, R of R. No, it's just, again, it's, gosh. How do I do this? Okay. I can do this by, I'm trying to think, right? Because yeah, if I set this to the current head.next, I mean, it doesn't change this thing, right? Temp next is equal to current head.next. This doesn't do anything. Okay, cur head is equal to head. Temp head temp next is equal to head.next. Head.next, we're just going to set this equal to none. We're going to say head is equal to temp next. Okay, and now, okay, so now we get rid of all that crap essentially. Okay, if it lets me run it. Okay, so now we're missing stuff. Okay, but now we're making progress. Now this should probably be less than or equal or something like that. Okay, so now we have too much stuff? No, we don't have enough stuff. Okay. Okay, so we get 1 and 4. So here I want to print my R, right? Let's print my array. One, 2, 3, 4. I want 1 and 4. Then I'll be at 1 and I'll be at 2. Zero, 1, 2, 3. Current head is equal to this one. Current tail is equal to this one. Oh yeah. Because now everything points to none, right? Okay. Okay. So yeah. So current head is equal to this. Current tail is equal to this. Yeah. So now, what we want to do is be like, hey. Okay. Curtail. Yeah, so this is our loop invariant. Now we'll say curtail is dot next is equal to cur head. Or no. Cur head dot no. Cur head dot next is going to be equal to the current tail. And the current tails dot next will be equal to R of L plus 1. And now do we have an infinity loop? Okay. Okay, okay, okay. We got it. 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 Okay, submit, 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 submit. Okay, even if this is the same type of complexity, okay, I accept this solution way more than the abomination we had before. Okay, okay, this is perfect. This is perfect. Okay, okay. Maybe I can do, well, this is less than r minus 1. Maybe we can do that. Maybe we can do that. And no, that gives us not enough stuff. So let's think about this. Let's think about this. L and R are directly with each other. Then I'll make my right, so this also works. Okay, okay, but now, okay, okay, it is actually much faster. Okay, it was just LeetCode doing a little bit of trolling there, a little bit of trolling. Step 2, set nodes, next values, respective to needed reordering. It's an r minus 1. If L plus 1 is less than R, then we'll do this. Tack, tack, tack. Okay, and now we can remove this guy. Ah, okay. To none. There we go. Okay, so submit this. Okay, okay, this works, this works. Okay, okay, this is a solution to be much more proud of. Handle last case with end of array of linked list, where end of linked list must be none. Honestly, we could have just made our life easier if here we just did r.append none, right? Or no, wait, we gotta relax. If we do that, then I'll make it the second element. Okay, okay. No, we could not have made our lives easier like that. Okay, okay, okay. We gotta relax. We gotta relax. Gotta relax. Relax, relax, relax. Of R, then there we go. Last case. None. Okay, step 3. Step 3. And the last case. That's fine. Okay, there we go. Submit. And there we go. Bada bing, bada boom. 0 MS beats 100%. That's what we like to see. So, okay, as always, in all my videos, I do a quick recap if I was able to solve the problem. So for this one, essentially, the very first way that I did it was just absolutely cheeky. Essentially, I took all of these nodes, I put them into an array. I then reordered the array itself in terms of this reordering over here. And then I went through all the elements in the array and I said, okay, the very first one's next is going to be the second element in the array. The second element in the array is next will be the third element in the array. Third's next will be the fourth element in the array, right? So it's like I put all the nodes in an array, reorder the array in respect to how it needed to be done for this problem, and then, you know, just iterate over the array to do other things, right? And so technically it's like, you know, I take O of n time to do, you know, put it all in an array. I take O of n time to, you know, reorder the array. And then I take O of n time to, like, you know, iterate over the array and put all the next values and so on. So technically the asymptotic complexity of that solution is O of n. You know, O of 3n is O of n. But again, it didn't feel that clean, so I didn't go with that solution. What I did instead is I said, hey, okay, we recognize first of all that in this problem, like, we need to set, you know, the first node's next value to be the last node in the list, right? So for sure, one thing I have to do is traverse the list entirely in terms of in its entirety, right? So, and then, you know, kind of keep track of that, right? So let's say, like, one thing I need for sure is like maybe a reverse version of the linked list where it's like, you know, I could take the original linked list, take the reverse version, and like add the nodes where I need them to be, right? But I need some data to keep track of, like, you know, the end of the list so I can go from there, right? So since, you know, I at least need to, like, you know, take care of like of an O of n, you know, reverse linked list in terms of memory, then I might as well use an array, right? I might as well use any data structure to store O of n worth of memory if I have to use O of n worth of memory in the first place, right? So instead of, you know, storing a whole new second linked list, I was like, you know what, let's just use an array with n elements inside. Each of the n elements will represent a node, right? And then one of the things I'm going to do is, as I add all the elements inside of here, I'm going to make the next values of each node equal to none, right? So here, actually, I can do auto depend head, and here, actually, I could have said head equals head.next, and r of -1 is equal to dot next is equal to none, right? And so something like this would have still worked. Yeah, so something like this would have still worked. In fact, it might be a little bit better. And there we go. Okay, so like 2ms, 0ms, and so on. We know that they work the very same way. Maybe it's just not as efficient to, like, you know, do these like queries inside the element array, regardless, and so on. The idea essentially is just like, hey, like we're gonna add every single node inside of this list, inside of an array here, and then for each node we're gonna make its .next value equal to none, right? Because the point is that we're gonna be modifying these .next values for the nodes. We might as well set them all to none and figure out what we actually want them to be, right? So that way we don't have, like, you know, insanely long linked list stuff that I was dealing with issues before. Let's just make our life nice and simple. Let's set them all to none for now, and then figure out how we want to do things, right? Then essentially what I did is like, okay, we kind of want, like, you know, a two pointers approach to this problem, right? Because really what I want is, like, you know, the first element is going to be the one on the very left. Then there's going to be the one on the very right. Then it's going to be the second leftmost one. Then it's going to be the second rightmost one, right? So what would be nice is, like, if we kept track of, like, you know, two pointers, it's like, you know, do our left pointer, do our right pointer, increment left, increment right. Do our left pointer, do our right pointer, increment left, decrement right, right? Do our left pointer, do our right pointer, and so on and so on, right? As we append these elements to our new list. The problem for this problem is that we need to modify the head in place, and we must not return anything, right? So what I did is I say, okay, what we're going to do is we're going to take the very left element, and we're going to take the very right element. What we're going to say is, like, okay, our current head is going to be the array at that left element, starting with L is equal to 0. And then our current tail is going to be the array at index R, which is initially going to be the very last element inside of our array, right? Which represents the linked list in its sorted current order, right? Then we're going to say, okay, what we want to do is, like, hey, we currently have, you know, L0 points to L1, points to ... points to L of n-1, points to Ln, right? So our current head right now is equal to L0. Our current tail right now is equal to L underscore n, right? Let's put an underscore here. Now what we want is, like, hey, we want to make it L0 points to Ln now, points to L underscore 1, right? And so here it's like cur head dot next is equal to L of 1, right? So essentially it's like, okay, what's the very first thing that we want to do? Well, okay, we know that cur head, well, right now they actually all point to none, right? Because we made them all point to none. So really it's like, if our current head is L0, we know that L0, we want that to be pointing to Ln now, right? So we're going to say, hey, what is Ln? It's our current tail. We're going to say cur head's next value is going to be cur tail, right? This is our cur head, right? So this is, I'll put ch here for this being our current head. And this is our current tail, right? And it's going to be the current head dot next, right? And there we go. So this is our current head, this is our current tail. So we want current head dot next value to be the current tail, right? So that's why I said current head dot next is equal to current tail. And then current tail's next value, we want it to be L of 1, right? So here we're going to say, hey, where's L of 1? It was cur head's dot next value, but we just modified cur head dot next. But cur head dot next is essentially the element at index L. So what are we going to put there? We're going to say, hey, if L0 was the element at index L, then L1 will be the index at L plus 1 here, right? So, and again, you might be worried like, oh, what if we go out of index and so on? That's why I did L is less than R minus 1. And here at the end, I just handle the very last case and so on, so that we don't have to worry about that, right? So like L plus 1 will still be less than R because it's like, here I should have made it while L plus 1 is less than R, right? Maybe that way it's a bit more readable. So that way it's like, yeah, I can put that L plus 1 in there, totally comfortable, no issues in the world, because that is still less than R, right? And then at the very end, we'll handle that last case. And so, but that's the point, right? So it's like, L1 is equal to, R at index L, R of L plus 1, right? So that essentially is like, that's my L1. So I said, hey, we want the current tail to be pointing to R of L plus 1 here, right? So that's why I say current tail.next is equal to R of L plus 1, right? And that way, when I do that, is like, okay, now I've gotten to the point where I say, hey, I am now, what do I care about, right? So now I've done L0, Ln, and now I'm at L1, right? So I have L0 pointing to Ln points to L1. Now I want to solve the rest of this recursively, right? Where it's like, now I want to, my left one ideally is my L1. And my right one now is my Ln minus 1. So I can keep doing this over and over and over again, right? So here I do L plus or equal to 1, right? Because it's like at index L plus 1 is where my L1 is, where I want to continue the problem from. So just L plus or equal to 1. So then I go to L1 from then on. And it's like, okay, what was right before Ln? Well, it's Ln minus 1, which is the next one that we want to do for our right pointer. In terms of an array, well, since we added everything inside of an array for the linked list, it'll just be at index R minus 1, right? So here we can just do R minus or equal to 1, and there we go, right? We'll essentially continue the problem where instead of, having L0 and Ln, we'll now do it with L1 and Ln minus 1, and we keep doing it over and over and over as long as L plus 1 is less than R. Then at the very, 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 very end, when we get to the very last case, we know that we need the linked list to terminate with a none. And then it's like, okay, it'll be the same spiel, the current head, the one at index L, will point to the current tail, but then the current tail will make it finally point to none, which we actually don't need because it's already equal to none, but just for clarification's sake, we set it to none, right? So therefore we'll terminate the linked list because, like, think about it. What's going to be at the end of the linked list here? It's going to be essentially the thing that's at the very, very middle, right? And so that's essentially how I handle that case at the very end. And then at the end, I just return, and there you go. Bada boom, bada bing, bada boom. Works super, super nice and efficiently. So here we can just resubmit, where we now have this L plus 1 just for, cleanliness to be respective to this index over here. And there you go. Okay, so like 5 ms beats 30% and so on, but like if we just resubmit a couple times, we might get it better, and we'll see. We got a 0 ms at some point. Okay, so now we're at 1 ms. If we did a little faster, got luckier, we would have had 0. But the point is, like, this is an optimal solution. It's O of n time. Maybe not optimal in space. I don't know how you would do this in O of 1 space, so I just use O of n space to make my life easy. And there you go, bada bing, bada boom. And hopefully that solution makes sense. But as always, let's make sure that we check off the fact that we did this problem. So now we're at problem 51 done out of 150, which means we're more than a third of the way done, which feels absolutely fantastic, and a good way to start our very first LeetCode medium linked list section here on the NeetCode 150. But that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment, and otherwise I'll catch you in the next one. So until then, ciao my friend, bye bye.